Assalamu alaikum wa rahmatullahi wa barakatuh. So in the protest tutorial we have seen how to simulate the different components connected to the microcontroller. Now in this tutorial we will see how to program the microcontroller using Mplab Snap programmer and debugger, and we will connect a similar circuit using PIC18F45K80 microcontroller, an LED resistor, and we will see how to use Mplab X to download the hex file to the microcontroller. So before we start, clean your work area and sanitize your hands and wear protective gloves. So the Mplab Snap is a new debugger and programmer for microchip. It is a new version which replaces PIC-Kit2, PIC-Kit3 and PIC-Kit4. And since it is a new model, it does not support all the microcontrollers. So we can find the list of microcontrollers supported by Mplab Snap in the release notes of Mplab X. So in Mplab, if you click on Help and select Release Notes and click on Mplab Release Notes for Mplab Snap and click on Device Support list, and this list shows you the supported devices for the different programmers available from microchip. So the first column is for the Mplab debugger, then the Mplab programmer. So both are same. So Mplab Snap can function as a programmer as well as a debugger. Then we have PIC-Kit4 programmer and debugger, then in-circuit debugger, ICD4. Similarly, we have other programmers and debuggers available in different columns. So as we see, the Mplab Snap supports only these microcontrollers which are highlighted in green. So if we search for PIC18F4580, we find that this programmer 18F4580 is not supported, but the 18F45K80, this microcontroller is supported. So this is the reason why we have moved from 18F4580 to 18F45K80 microcontroller. So the 45K80 microcontroller is the enhanced version. It is the enhanced version of 18F4580 microcontroller. Now how do we connect the Mplab Snap debugger? So we have seen in the schematic diagram given in along with the Mplab Snap, the schematic diagram, this diagram which was given to you in the box of Mplab Snap. So there are several ways to program a microcontroller. So all these programmers, Mplab Snap, PIC-Kit4, in-circuit debugger, PIC-Kit3, PIC-Kit2, PM, ICD. So all these programmers can be used to program the microcontroller, the PIC microcontroller. But one thing is common in all these programmers, which is the pin connection, the connection from the programmer to the microcontroller. So let us look at the standard connection for any programmer with the PIC microcontroller. So here, this is the user guide. This is the user guide for Mplab Snap, Mplab Snap users guide. And here in this section, we find the explanation for the connections with the programmer and the microcontroller, between the programmer and the microcontroller. So for any programmer, whether it is Mplab Snap or PIC-Kit2 or in circuit debugger, we use 5 pins between the programmer and the microcontroller. So pin number 1 of the programmer is connected to the MCLR pin, the reset pin of the microcontroller. Then pin number 2 is connected to the VDD, the power supply of the microcontroller. Pin number 3 is connected to the ground, and pin number 4 is connected to PGD, programming data, and pin number 5 is connected to PGC. So this is the standard connection. So this is the standard connection for any programmer with the PIC microcontroller. So whether it is Mplab Snap or PIC-Kit 2 or PIC-Kit 3 or in-circuit debugger or any other programmer. So same way for Mplab Snap, let us look at the pin diagram. So before that, here in this section 3.2.4, it shows you some of the improper circuit components. So the MCLR pin should always be connected, as we have seen previously in the protest tutorial. The MCLR pin should always be pulled up. It should be connected with a resistor to VDD. So we should not connect a capacitor to the ground, or we should not connect the MCLR pin to the ground. Similarly, the PGC pin should not be connected to power, and because PGC is the programming clock, it should not have a diode connected in this way, and the PGD is the data pin. Again, it should not be connected to the ground. Now let us look at the pin diagram of the Mplab Snap debugger. So you can find the pin diagram here in section 10, hardware specifications here. So this is the picture of the Mplab Snap. And these are the pins of the Mplab Snap programmer and debugger. So it has 8 pins, but once again we'll only use the 5 pins. We'll only use the first 5 pins from this programmer. So what is the first pin? The first pin is the MCLR pin, the master, clear and reset pin. So this is connected to pin number 1, MCLR pin of the microcontroller. Then the next pin is the VDD pin, the power supply. Again, this will be connected to the VDD of the microcontroller. Then we have ground. This should be connected to the VSS of the microcontroller. Then we have PGD. PGD is the programming data pin. So this is the pin on which the data is transferred from the laptop of the PC through the programmer to the microcontroller. So PGD, the data, which is the hex file, is serially transferred from the programmer to the microcontroller using the PGD pin, the programming data pin. And this pin on the microcontroller side is pin number 40. So it is pin number 40 of the microcontroller. Then we have PGC. So since we are connecting two different boards, entirely different boards, and the Mplab Snap works at a different clock frequency, and the microcontroller, PIC microcontroller, it runs at a different clock frequency. So in this case, there must be a synchronized clock between these two devices. So PGC is used to synchronize the clock between the programmer and the PIC microcontroller. So these are the 5 pins. These are the only 5 pins that will be connecting between the Mplab Snap and the microcontroller. The remaining 3 pins are not connected. So the pin diagram is given here, the schematic layout is given here. So the first pin is indicated by the arrow here, and that is the MCLR pin, and that is connected to pin number 1, which is MCLR pin of the microcontroller, as we have seen before in the pin diagram. Similarly, the next pin, VDD pin, here is connected to the power supply, 5 volt, and it's connected to VDD of the microcontroller. Then we have VSS connected to VSS of the microcontroller, the ground of the microcontroller. Then we have PGD connected to pin number 40 and PGC connected to pin number 39 of the microcontroller. Now to power up the microcontroller, we must connect 5 volt, and since we are using a 9 volt battery, we are using the LM7805 voltage regulator, and this voltage regulator converts the 9 volt into 5 volt output. So the first pin is the V-in pin, the input pin, and you connect the battery directly to the input pin, and then we have ground, the center pin, and the output pin is on the right side. So here we get 5 volt, and this 5 volt is connected to the power rail on the breadboard, and then we connect these capacitors to smooth the power supply, and MCLR is connected with a resistor, 10k resistor, which is connected to the power VDD. So MCLR is pulled up, and this is how we power up the microcontroller. And then for the Mplab Snap, connect a USB cable, a micro USB cable or a data cable, and we will see in Mplab X how to import the hex file and how to download the hex file now. So let us build our circuit now. So as it was explained previously, the LM7805 IC voltage regulator is available in this packet. Let's connect it here on the breadboard. Follow the schematic diagram given there. So we'll connect these capacitors in the power supply. So 104 is a 100 nanofarad capacitor which is connected between VDD and ground, and we have a 10 microfarad capacitor connected on recap pin, which is pin number 6 of the microcontroller. The negative side should be connected on the ground. So pin number 11 and 12, VDD and ground, they are connected with a 100 nanofarad capacitor. Similarly on the other side, you have pin numbers 31 and 32 and a 10 kilo ohm resistor connected on the MCLR pin. Keep all the unused components back in the packet inside the box. Now let us connect Mplab Snap. The first pin, which is pin number 1 here, is this one, number 1. This will be connected to MCLR. The second pin is the power connected to VDD, so we'll connect it here. Third pin is the ground, it's connected here. And then we have programming data PGD on pin number 40 and PGC programming clock on pin number 39. So this is the connection that we have done just now. Now they are still not powered up. The battery is connected here, but the output of the battery, output of the voltage regulator, is still not connected to the VDD of microcontroller, and the Mplab Snap is also not connected to the laptop or the PC. So first let us connect the power and ground of the microcontroller with the power and ground power rail on the breadboard. So pin number 11 is the power, so we are connecting it here on the positive line, and pin number 12, which is ground, connected on the negative line. Now before connecting Mplab Snap with the PC, let us power up the microcontroller first. So if you have a multimeter, before you connect the microcontroller, if you have a multimeter, make sure that you get 5 volt on the output pin here, on this pin of the voltage regulator. So using a multimeter, just check whether you have 5 volt on this pin of the voltage regulator. And one more connection that is left here is connecting a common ground. So we must have a common ground, so the ground of the voltage regulator should also be connected to the ground rail on the breadboard. So let's power up the microcontroller here. Bismillahirrahmanirrahim. Okay, so the microcontroller is now powered up, and let's connect Mplab Snap with the PC. So use a Samsung data cable. I use micro USB cable like this, and connect this with the Mplab Snap and connect it to the USB port. So as soon as it is connected to the USB port, you will see the power LED on the Mplab Snap is switched on. So that means the Mplab Snap is active now, and you can start programming the microcontroller. That means you can start downloading the hex file to the microcontroller. So let's also connect one LED to the microcontroller. So let's connect an LED, one of the LEDs that we have seen in the port simulation. So we have seen 4 LEDs connected on port D of the microcontroller in the simulation. So let us connect one LED out of those 4 on port D of the microcontroller. So before connecting the LED, we have to identify the anode and cathode pins of the LED. So how do we know, or how do we find out which pin is the anode pin and which pin is the cathode pin? So there are 3 methods for this. So this is one of the tutorials in Lab 0. So we have seen here the anode pin of an LED is longer than the cathode pin. So this is normally for a new LED. If you have a new LED, you can easily identify the anode and cathode pins of the LED by looking at the long pin. The long pin is the anode pin, and the short pin is the cathode pin. So what is another method? So what if the LED is already used and the legs of the pins of the LED are already bent? So how do we identify which pin is the longer pin and which pin is the shorter pin? So in that case, what we can do is we look inside the LED. So if you look inside the LED, you will find one of the terminals is a big terminal and the other terminal is a short terminal. So inside the LED, the bigger terminal inside the LED is the cathode terminal, and the shorter terminal or the smaller terminal inside the LED is the anode terminal. So it is opposite. So the longer pin is the anode pin, but inside the LED the bigger terminal is the cathode terminal and the smaller terminal inside is the anode terminal. So this is another method to identify the anode and cathode of the LED. And there is a third method. The third method is by looking at or by feeling the plastic case of the LED, and you will find the LED cover is circular, it is round, but on one side, on the cathode side, you can see it is flat. You can feel it with your finger. The cathode side is flat, and that will help you identify the cathode pin of the LED. So let us connect this LED to the microcontroller. So in the simulation, we have connected them on RD 4, 5, 6 and 7, which is pin number 27, 28, 29 and 30 of the microcontroller. And these pins are on this side of the microcontroller, on the other side of the microcontroller. So let's start with a resistor. So in the packet you will find a 330 ohms resistor. So in the packet you will find 330 ohms resistors. So you use one of these resistors here on one of these 4 pins, pin number RD 4, 5, 6 or 7, which is pin number 27, 28, 29 or 30. So I will use one of these pins here. And the anode of the LED should be on the microcontroller side. So the anode of the LED should be on the microcontroller side, and the cathode should be on the ground side. So this is connected. So the resistor, the edge of the resistor and the anode pin of the LED, they are connected on one line. The other edge of the other pin of the resistor is connected on one of the pins of the microcontroller, port D pins of the microcontroller, and the cathode of the LED is connected on another line here, on this line, and this will be connected to the ground. Now since this microcontroller is not running any program, it does not have anything, the program memory is blank, so we don't see anything here, we don't see anything on the LED. So let's program this microcontroller now. Let us download the hex file, the same Proteus tutorial hex file that we have seen in the simulation. Let's download the same hex file to this microcontroller. So how do we do that? Let's go back to Mplab X. So in Mplab X, click on File, click Import hex file, the pre-built file, because the hex file is already given to you. Then browse and go to the folder where you have downloaded the Proteus tutorial.hex file. So go to the folder where you have downloaded Proteus tutorial.hex file. Select this file, open, select the device. So the device that we are using now is 18F45K80. You can type the name here directly. Now in the hardware tool, if you click show all, you will find these are all the different programmers and debuggers which are available for this particular microcontroller. Now we are using Mplab Snap, so select Mplab select Snap. So you have selected the Proteus tutorial hex file and the device as pick 18F45K80 and hardware tool Snap. Click next. You can write the project name as a tutorial and click finish. Now to program the microcontroller, this is the main project now. Right click for this tutorial, right click and set as main project. Then click on this button, to download the hex file to the microcontroller, or we can click on this button to run this hex file. So when you try to program the microcontroller using this button, if it says snap not found, then that means this cable is not compatible. You'll have to change the cable. So when you connect the proper cable for the first time, you will see Windows will show you Mplab Snap is found, and it will try to install the drivers for this Mplab Snap debugger and programmer. So now you can, so when the drivers are installed, now you can program the microcontroller properly. So I have changed the cable now here. Mplab Snap ICD is detected and the microcontroller is powered up using the battery. Download the hex file first using this button. Okay, you can see connecting to Mplab Snap. So on the first try, it will try to update the firmware. So it says here the requested operation cannot continue with the following configuration bit: master clear enable, MCLR is disabled, RB3 is enabled. So it's okay, we can continue. Okay, it says programming verify complete. So after you have programmed the microcontroller, you'll find this LED is switched on. The LED which is connected on pin number 28 is switched on. So it is running the program inside the microcontroller now. So after completing this tutorial, disconnect everything. Disconnect the Mplab Snap, disconnect the battery first to save power, and disconnect all the components and keep them back in the kit. So that is all for this tutorial. Practice using Mplab Snap to download the hex file to the microcontroller, and we'll be using this Mplab Snap in the upcoming lab activities. So wassalamu alaikum wa rahmatullahi wa barakatuh.